Hi again. Welcome to Lesson 3 on Designing Database Solutions with Microsoft SQL Server 2019. For today's topic, you are going to learn how to set up some of the important column properties of your database table like Identity Specification, Default Value, and Computed Column Specification. You'll understand the basic concepts of indexes and keys by creating primary key and unique keys in your table. You'll also learn how to properly set up check constraints to limit or restrict unwanted values in your database table to maintain data integrity. To illustrate these concepts, I'll be using the same database that we use in Lesson 2. In the My Company database, I only have one table here from the previous lesson. I'll open the table design view for the employees table and I'll edit the top 200 rows to see what we have entered last time. So far, we only have 2 test records. When creating tables in your database, you don't want that these tables will hold similar records repeatedly. Not only that it consumes additional space, which is a waste of storage, but it also affects the integrity of your database. It will be prone to data inconsistency. That's why the usual thing that you will notice for most of your personal records is that it always has an identity number. Like if you are a student, you have a student ID number. If you drive, you have a driver's license number. And if you're an employee, you have an employee number. The purpose of this additional field is to uniquely identify each record stored in a database table. We called it the primary key. It is one of the most important things that you should always include when creating a table. In our employees table, I'll add a field name employee ID and set its data type to int. I want this employee ID to be mandatory, but most importantly, I want it to be unique in this entire table. To set this as the primary key, you can either click this key icon on this toolbar or right-click on this employee ID field and select Set Primary Key. Notice the key icon that appears prior to the field name. If you already have existing records, saving this table will definitely trigger an error. Since we already have 2 records in this table, creating additional field that doesn't accept null will conflict with these existing records because it will try to add a field that is null. So it is always a good practice to have your primary key identified right away when you create your table. I'll delete these 2 records and then go back to the table design again and click Save. Now, it allows me to save the changes that I made. In addition to this, it is a good practice to always put your primary key as the first field in your table. You can move it by dragging this field all the way to the top, and then I'll click Save again. When you modify the structure of your table and the Edit Top 200 Rows window is open prior to making the structure change, you'll notice that the changes you made is not reflected automatically. All you have to do is to close this window and reopen it again. Now, let's start typing some values here. I'll put 101 for the employee ID, then Go, Joed, Escobar, Staff, January 1, 2020, and then 15,000. And then false. Since the employee ID field is set as the primary key, it must be unique. If I enter here an ID that already existed in this table, and then try to commit the changes, I'll get an error message that says violation of primary key constraints. I can either correct the error and then try again, or press the escape key to cancel the changes that I made. So let's change the employee ID and set it to value 102. And it saved successfully. In this field, since we only use a simple integer value, and if we intend to have an employee ID that continuously increments its value for every record that we add, then we can easily modify it here in the table designer. Make sure that the employee ID field is selected, and then at the bottom part of this screen, you will see the column properties window that contains all the properties pertaining only to this employee ID field. Scroll down at the bottom portion of this properties window, and you'll see the Identity Specification property. Open it, and under this, you'll see the Is Identity property set to No. To change it to Yes, simply double-click on this field. After that, you'll see 2 sub-properties that are also activated, the Identity Seed and the Identity Increment. Identity Seed is the starting number that you want for your first record to start with. Say I want my first record to have an employee ID of 101, then The identity increment is the increment value that is added automatically for the next record. So if I started 101, the next record's employee ID is 102, then 103, and so on. Let's go ahead and save this and edit the top 200 rows again. Now, notice that the employee ID field is already grayed or disabled. You can no longer type any value here because it is set to be auto-generated by the SQL Server engine for every record that is added. I'll add a new record, say go, mark as a security, then true, and when I press the enter key, the employee ID is automatically set to 103. When a field's identity specification is set to yes, it will automatically increment regardless of whether the new record we try to add has succeeded or failed. To understand what I mean, I'll try to add a new record and deliberately violate the rule so that the record will not be committed. I'll enter here the last name of XXXX and then press the enter key right away. This will cause an error of cannot insert null value. That employee ID number should be 104. And I'll do it again by typing YYYY and then press enter key. That employee number should be 105. And then I'll enter it correctly at this time. And when I press the enter key, notice that the employee ID value that is generated is 106. Well, that is totally fine because eventually you'll learn how to create your own function that returns a customized ID number based on the business rules of your organization. But if you're really conscious about this skipped ID number, the workaround here is go back to the table design and then set the isIdentity property to no and then save it again. Then edit the top 200 rows again and change the employee ID manually. I'll set it to 104. I'll close it and then go back to the table designer again and change the isIdentity property back to yes. With identity seed set to 101. Save it again, and when we go back to edit the top 200 rows, you can continue to add new record using the auto-generated ID again. Let's test it by adding a new record. And there you have it, an employee ID of 105 is automatically assigned. Aside from the primary key, there may be fields in your table that need to be unique as well. It doesn't need to be a primary key, but it is a must that this field or set of fields must be unique as well for data consistency. For example, if I add an email field here, I'll use nvarchar50 and then save it. Definitely, you would want that each employee will register his or her own email address that is unique. But with this current table design that we have, no one will restrict me from entering exactly the same email for 2 or more different employee records. And this is in a way violates data integrity. I'll set it back to null. And going back to the table design view, I'll right-click anywhere in this area. And from the context menu that appears, I'll choose indexes or keys. This opens a dialog window to let me manage all my existing keys. Notice that it already has a pk_employees, which is our primary key that we have set earlier. To add another key field that is unique to this table, I'll click the Add button. The initial name that was given is ix_employees. Then I'll change the isUnique property and set it to yes. And the type, I'll choose unique keys. And of course, most importantly, we need to specify the column or columns that must be unique. By default, it is set to employee ID, but this time, I want the email field. You can leave the default sort order to ascending and click OK. If you created a unique key, a good practice is to change the name of this key that starts to UX for unique instead of IX for index. Then I'll close this dialog window. And now, watch that if I try to save this, an error will occur. We are unable to create this unique key because apparently we have records that violates this rule. We have duplicate keys. And according to SQL Server, these are the null values. So what we can do is to edit these existing records and enter a unique email address first for each record. And then, if I want this field to be mandatory now, I'll uncheck this Allow Nulls checkbox and save the changes. Now, we have a new restriction that is set. And if I try to edit this record either accidentally or intentionally, storing the same email address for these fields more than once will cause an error. And basically, this is the main idea why we set constraints in the first place. Rules must be established first during the design, before records are added to it. It's illogical to have thousands of records first before realizing that you need certain rules that must be followed. Database design is all about anticipation. To be a good database designer, you must understand everything that is needed by a certain organization to come up with a well-suited database design. Planning will take some time. Gather all the available documents, files, reports, and so on, so that you'll have a holistic picture of the entire organization's data and process flow. From here, you'll have a good idea what tables can be built and the fields that each table should contain. And then, for each table, what are the fields that require restrictions so that it doesn't accept garbage data that can mess the record's consistency. When setting unique keys, you can apply it to affect multiple fields. For example, even if 101 and 103 are unique, I can easily enter exactly the same last name, first name, and middle name combination in any of these records, that in effect, creating duplicate employee records with two different employee IDs. So to set this kind of restrictions, go back to the table design view again, right-click and select indexes or keys, and we'll add another unique key. If I change the name to UX employees, you'll get an error message saying name already exists. So if you have multiple keys in your table, the naming convention is to include the field names that your key is affecting, like last name, first name, and middle name, or if you want, simply name. Then, set the is unique to yes and the type to unique key. In the columns that must be unique, I'll choose the last name together with the first name and middle name. It simply means that no records with exactly the same last name, first name, and middle name combination must be allowed. I'll close this dialog window and click Save. Bear in mind that we have two unique keys aside from the primary key in place here. First is the unique key on email field, so I'll use a different email here. And now let's try changing the first name of employee 103 to Joed, and this is perfectly fine. These two records have the same first name and last name, but they are not the same person because their middle names are different. But if I type the exact middle name here, notice an error on violation to the unique key constraints was thrown. So I'll edit the record back to a unique name, and it works fine. Another column property that might be useful when you enter a new record to your table is the default value. Since there are fields that contain repeated value, like in this designation field for example, currently we have values like staff, manager, and if we expect that one of these values will exist in these fields several times, like the value staff, assigning it as a default value or binding will speed up the data entry process. The value that you must place in this column property must match the data type for this field. Characters as well as dates and time need single quote on both ends. However, in numeric type, you just simply type the number itself. I'll save the changes and edit the top 200 rows again. I'll enter a new record, Andre Mac, and in the designation field, I'll leave it as null, and continue assigning values for the remaining fields. And when I press the Enter key, notice that this record is grayed out, which means it is already committed to the database, but the editor window is unable to display its updated content. All you have to do is to right-click anywhere here and choose Execute or Ctrl-R, and there you'll see the updated employee ID 106 with a designation of staff. The value staff is automatically assigned when we leave the field to null when entering a new record. Now let's try this default value for both the monthly salary and the date hired fields. For the monthly salary, I want that if I don't enter anything, the default value is set to 10,000. However, in the date hired field, if I leave it null, I want the current date to be stored. You might be tempted to type a string literal for today's date like this. It might be good if you enter all records just for today, but for tomorrow, the current date will be different. So I'll use one of the built-in functions here in SQL Server, the getDate function. Functions, denoted by this pair of parentheses at the end of the function name, usually perform an action and return something when called. Like this one, it returns the current system date and time. We'll work with several functions in some later videos as well. Let's save this and then go back to Edit Row window. Let's add another record, Onera Mia, and then I'll leave the designation, date hired, and monthly salary as null. I'll update this window by clicking the Execute SQL context menu, and you'll see the three default values working properly. Now, if you want to create your own specific set of conditions for a specific field based on your business rules, like this monthly salary for example, I can easily store any value here that is not supposedly acceptable. Say, I added 2 zeros here, either intentional or accidental. The problem is that it will still be accepted. This employee has now a monthly salary set to 1 million. I'll set it back to 10,000, and to add a restriction to any field like this monthly salary, you cannot see any properties here that will do the trick. What you can do is to right-click anywhere here in the table design, and from the context menu, select Check Constraint. A Check Constraints dialog window for this table appears. Click the Add button, and then I'll rename this to CK_employees_monthly salary. Then, I can put a description that says, must be within 10,000 to 150,000 range. Under the expression, you can type directly here or click this ellipsis button to start typing your check constraints expression. I'll say that the monthly salary must be greater than or equal to 10,000 and monthly salary is less than or equal to 150,000. And then click OK and close this window. I'll save the changes. And now, if I edit this value from 10,000 and make it 100, an error message appears saying that it is not updated. There is a conflict with the check constraint, which is good. I'll test it one more time. Make it 200,000. And as expected, it throws an error. I'll set it to 14,000 and it is within the range in our condition. It will be accepted. You can apply multiple check constraints to any field that you like. For example, in the last name field, if you want to restrict a specific value to be entered, say Gibson, hypothetically for some weird reason, you don't want the last name Gibson to be stored in this table. So to do that, I'll reset this last name to Onera, and then I'll add another check constraint. In the name, I'll change it to CK_employees_last name and put a description, Gibson is not allowed. In the expression, I'll type last name, less than greater than means not equal in T-SQL. You can also use the not equal operator commonly used in C-related languages. I'll save it and try to edit this last name Onera to Gibson, and as expected, it gives me an error. I'll change it back to Onera again, and it works fine. Another column property that you might find useful is the Computed Column Specification. Let's say we add another field and we call it bonus. I'll use small money as the data type, and I'll allow nulls. I'll save it and reopen my table row editor. Here you see the bonus field with nulls in it. Say I want that the bonus value to be 10% of whatever is their monthly salary. So for 15,000 monthly salary, the bonus is 1,500. For 12,500 salary, it will be 1,250. The problem with this is that it is prone for inconsistency. No one will restrict me from accidentally placing here, say 5,000. And if you want that this field is computed based on the other field's value, then go back to the table designer and select the bonus field. Look for the Computed Column Specification, open it, and under the formula, I can type here any valid expression like monthly salary times 0.10. I'll save the changes one more time, and when I click the Edit Top 200 Rows, you see that the bonus field is grayed out and it has values already computed from the monthly salary field. I encourage you to practice on the things that you've seen here and familiarize yourselves with the different column properties and constraints that you can set to make your table design healthy and free from any garbage data. As a challenge, try to create a table with the following fields: booking ID, customer name, screening date, screening time start, screening time end, seat number, regular ticket price, and advanced screening price. This is your practice table for advanced movie screening. When designing this, you must follow the following conditions. The booking ID must be auto-incremented by 1 with starting value of 2001. The customer name must accept up to 50 character max. The screening date, when leave null, must get the current system date. The screening time start and time end must be in 24-hour clock format. However, the screening time end value must always be greater than the screening time start. The seat number is only available for seat number 101 up to seat number 199. The regular ticket price value must range from 200 to 250, and the advanced screening price has an additional 12% on top of the regular ticket price. I'll execute to update the view. I'll test another record, and this time I'll set the screening time start bigger than the time end. Here, an error must be thrown. I'll update it again with the correct value. I'll add another record, and this time the table must not accept duplicate records of moviegoers with the same name on the same date with the same screening time and seat number. I'll change the seat number and the customer name, and it works fine. Let's test the remaining constraint. I'll put 0 to the seat number, and it fails. I'll put 500 to the regular ticket price, and it fails as well. And that's it. Up next, we're going to start writing SQL commands. Again, thanks for watching. I hope that this is helpful to you, and if so, please click the like and subscribe button for more programming tutorials. This is Joe Edgo, and hope to see you in the next video lecture.